This video is going to help us with composite shapes, and the main focus is going to be on a shaded area and a non-shaded area. So a lot of times people ask, when am I ever going to use this in real life, and why do we need to learn it? So I have 3 picture examples on this first slide that shows examples of when we would apply this content that we're learning today to real life applications. The picture in the middle of the swimming pool, if I were to take this area that has been tiled and I wanted to know just the amount of space I need for the tiled area, I could do this big rectangle if I had the full picture, and then the place where the swimming pool is actually filled with water has no tile in it. So I could subtract this area in the middle for the swimming pool, and then what's left over would be all the amount for tile. Another thing could be the example on the left. This is a design or a sketch of a yard area. So the grass is in green. There is a big flower bed in the center. So if this shape in the middle of the flower bed was a perfect circle and I was just trying to put new grass in my yard, I could take the whole area of my yard and then I could find the area of just the flower bed and subtract it out to know exactly how much grass or sod I would need to purchase. The one on the far right is a design of a house or an entire lot for where someone lives. They have areas that's mapped out for the sidewalk, so that would be a concrete space, a driveway, and then they also have the area where their house is located. And then all the green spaces would be the grass. So if I was needing to resod my yard, I could take all those spaces, which would be compound shapes, which we've also talked about, or composite shapes. This area right here isn't just a plain shape all alone, but I could break it up and find the area of that space as well. The first example we're going to look at is going to deal with the shaded area, and we're going to end up subtracting the non-shaded area, or the space that's been cut out and is no longer there. The first step we're going to do is identify the shape. If you look at the overall outline of what used to be shaded, this would be a triangle, and I'm finding the area of it. If I want to find the area of a triangle, I need to think about what is the formula. If you forgot what it was on our chart, it says half base times height. On a triangle, which is in this picture, the base is 6 and the height is 7. 6 times 7 is 42, and then I want half of 42. If you're not sure what that is, you can divide it out. If not, the answer is 21, and this picture is measuring in meters. So the original shaded space is 21 meters. The next thing I'm going to do is find the non-shaded area, and then again I'm going to subtract it. So when we look at this non-shaded area, or what's been cut away, that is a rectangle. And the way you find rectangle, its area is just base times height. If we go back and look at that, they have labeled it really nice for us. We have one dimension is a 4 and the other dimension of the rectangle is a 2. It doesn't matter which one we choose. If I want to say the base is 4 and the height is 2, that should give me a total of 8 square meters that have been cut away or removed from the space. The final step is going to be to subtract. So I would just do 21 minus 8, and that would be 13 left over. That is the remaining shaded area. So I would say 13 square meters, or 13 meters squared. The second example is a combination of a rectangle and a circle. Again, the first thing I'm going to do is identify the shaded space. So I can start with the background. Overall, I've got the rectangle in the back. So step 1, I have my large rectangle that used to be completely shaded. To find the area of a rectangle is base times height. In this particular example, base is 7, height is 12. If you work out 7 times 12, you should get 84. So right now, I'm thinking this whole thing was 84, but someone cut a circle out of the middle, so I need to subtract that away so I can get just the remaining shaded space. The non-shaded area we just said was the circle. And to find the area of a circle, it is pi times r. And I like to put times r again instead of using the exponent, but if you would rather do that, you can. The radius of a circle is only halfway across. So right now it's telling me the full distance across the circle, because the arrows go from one side to another, is 4. If I only want to go halfway across the circle, that would only be 2, since the whole distance is 4. So now I'm going to put those numbers in that spot. Radius is 2, so I'm going to do 2 times 2. 2 times 2 is 4, and the number we use for pi is 3.14 or 3.14. The final step for this white non-shaded area is 3.14 times 4. I'm going to do that real fast. 4 times 4 is 16. 4 times 1 plus 1 is 5. And 4 times 3 is 12. Then we want to look back and see how many digits are behind the decimal. We have 2. So in my answer, I need 2 digits behind the decimal. The final step that we need to do is take the shaded area and subtract out the non-shaded area. In this one of our numbers is a decimal, so we're going to have to be super careful. The shaded space is 84. The non-shaded space has a decimal in it. So therefore, I need to make 84 have a decimal too. So I'm going to make it be 84.00. Now I can line up my decimal and subtract 12.56. I'm going to need to borrow so that I have enough to subtract over here. 10 minus 6 is 4. 9 minus 5 is 4. I'm going to carry down my decimal. 3 minus 2 is 1. And 8 minus 1 is 7. So the remaining shaded space after the circle's been removed is 71.44. And this particular example is in yards. So I would say square yards. Final answer for this is 71 and 44/100 square yards. Hopefully this helped you, and something you might take away and think about is we all have problems, but if you count your blessings instead of your problems, hopefully that will keep you in a happier mood.